Excellent. Great. So thank you all for joining us today. Good morning and good afternoon, wherever you might be based. Thanks for joining today for this very exciting webinar based on the SafeXtend project, which aims to transform the construction industry and productivity with training through AI-powered virtual reality. However, I'm not the best person to explain all the finer details to you, which is why I have a wonderful team of experts here who will take you through the SafeXtend project today and answer any questions that you may have. So with any questions that you do think of throughout today's presentations, please feel free to send them in the Q&A box and we'll answer as many as possible after each presentation for the individual speaker. And then any leftover ones we will do at the end of the whole session. And if you can just add in who your question is for, that would be really useful for me. Like I said, I'm not the most technical, so I don't know who'd be best to answer the question. So yeah, if you can just pop the person's name on your question, that would be much appreciated. So thank you very much. Really hope you enjoyed today's session. And yeah, look forward to hearing all your questions and we look forward to hearing from all of our presenters today. So thank you, and I will hand you over to our first speaker, Dr. Edgar Segiova, who is an energy consultant at VLab. Thank you, Edgar.
Yeah, good morning. Thank you for being here. Thank you for the introduction. Yeah, my name is Edgar Segovia from VLab, and I will introduce this webinar. Before let me share my screen. Can you see my screen? Great. Before I start, I will introduce this webinar. And before I start the presentation, I would like to introduce SafeXtend as a project. As VLab, we are leading this project, and this project born to address the urgent need to scalable skill target training solutions in construction industry through innovative AI-powered virtual platform. The objectives of the project are 3D scanning construction sites, AI drive scenarios generator, VR-based training simulation, customized learning experience, and continuing improve and adaptation. That are the objectives of this project, and this project is the one that make possible this webinar. Now, to start with the introduction, I divide this presentation in 3 sections: an introduction for VR training, benefits of VR training, and challenge of VR training. And to finalize, we have a question session. So feel free to question everything that you want to ask. So I will try to answer everything after the finish. To start, maybe a question for the people that is not very familiar with virtual reality is, what is a virtual reality? And maybe you are thinking about the equipment, many different equipment, the headsets, the treadmill, maybe the handheld. What is a virtual reality? Maybe some people think, no, the virtual reality is more about the environment, the people, the interactions. Well, let's see what we can find in the literature. And I find these 3 good definitions for virtual reality. The first one is virtual reality is a high-end user-computer interface involving real-time simulations and interactions through multiple sensorial channels, creating the illusion of being present in virtual environment. The second one is virtual reality is an immersive interactive experience generated by computer where the user can explore and manipulate a virtual environment as if it were in the real world. And finally, the last one is virtual reality is a medium consisting of interactive computer simulation that sends the participants' position and action, providing kinetic sensor feedback to one or more sense, giving the feeling of being immersed in simulation. We can see many similar words, as for example, interface simulation, interactions. In the second one, we can see explore and manipulate, that can be similar to interaction. Virtual environment. I think with that three definition, with that high words, you can have a good understanding about what is a virtual reality. But if not, I bring this virtual continuum line, in which you can see the continuum from reality to virtual, in which we have here the reality, in which we don't need any headset to see the reality, is the environment where we live and where we can interact without necessity of any virtual boundary. In other hand, we have the virtual world, where we need the headset to interact with virtual environment, but we cannot interact with the real world. So that in the real world, we cannot interact with virtual objects, and in the virtual world, we cannot interact with real objects. But there are many options in the middle. For example, augmented reality, in which we are in the real world with some elements from virtual world. Maybe the most famous app that bring augmented reality to the hands of everybody is Pokemon Go, in which you can walk in the real world and see many different aspects from a virtual world in the real world, but you still need to walk and move and and be in the real world. Then we have the mixed reality, in which there is a full combination between reality and virtual, and the objects of the virtual reality can interact with the objects from the reality. And finally, we have VR, the object of this presentation, in which we can fully interact with virtual objects. Okay, now that we know what is VR in training? VR in training could be seen like the combination of VR techniques with the training techniques to training people to make works. That give many benefits, as for example, the opportunity to personalize the experience, the opportunity to not have any boundaries, geographical boundaries, so you can be training in any geographic because you move in the virtual world, not in the real world, as could be in augmented reality. In a virtual reality, you can move without move physically. And finally, and maybe the most important for this presentation, is the safety. You can be training, and the people can be training in a virtual environment, in a safety environment. The name of the project is SafeXtend, because the safety. But safety is not an accident. For that reason, the people have to be trained before be in a construction sector, working in a construction sector. 88% of the accidents in constructions happen because of human error. So if we can reduce the possibility of human errors by training, we can reduce the quantity of accidents. Here you can see the normal timeline of training. Normally, the people that is training receive a documentation, can be books, can be flyers, that explain in detail what they have to do, and what they will see in the space where they are training, which type of PPE they have to wear. It's information they have to read and learn. That information could be digital. There are videos, audios that are preparing in this moment for training people for being in at constructions, but also for different other reasons that could be extrapolated to any other area for training. And finally, we have tests, in which the people prove that they learn this information before go to the real training. And if they pass the real training, the training in the real world, they can work they can work. The idea is put virtual reality in the middle to make more smooth path to the real world training. so the people can pass the test, so they have the knowledge about what they have to do. They can test it in a virtual safe environment, and then they can go into the real world training with more relaxing and with more knowledge, and it's not the first time that they are facing that hazard. They faced it before in the virtual reality, and also if they have the knowledge, they don't face the hazards until they are here, until they have the virtual reality training. The other option that we propose is retraining. So there are many of these trainings that have to be repetitive every year. With the virtual reality, they can come back and be training in the virtual reality, and then come back and be training, saving time and reducing of and increasing the possibility of pass the real world training. Speaking about the benefits of VR on training, I already mentioned three: the personalization, the absence of geographical boundaries, and the safety, and finally the safe exposure to high risk scenarios. If we go into the first one, the adjustment of difficulty, the personalization can see from three perspectives. The adjustment of difficulty, so we can adjust the difficulty of the training for the client or for the people that is doing the client the training, so they can face level 1, then level 2, then level 3. But using the feedback, we can see in which level they are, so they save time. And if they have to start in level 3 because they need that level, they can make a progression until they achieve the level necessary for go to the the real world training. The personalized learning path that will help the people that have problems in some part of the training to focus on that part of the training and not focus in the whole training. And finally, and maybe the most important one, is the individualized feedback and evaluation. The VR world give all the possibility to measure different things that can not be measured in the real world. For example, the timing, what the people is focusing, what the people see during the virtual training, and use that feedback to improve the experience in the next time that they do it if they fail. Then we have the absence of geographical boundaries. That is maybe one of the most important for many people. And we can say, for example, the remote access high quality training and high quality international certificates. Using VR training, it's possible training everybody in anywhere until they have access to VR equipment and internet. With that one, we can get certificate for different countries from different agencies more easily than it is now, because now we have to travel physically and be there and be training for that especially. Then we have the virtual collaboration across borders. Again, we can cross borders without any restrictions, because in the VR, in the virtual world, not in the real world, we can cross all the borders, because in the virtual world there is not legislation, but there is not any legislation that say, well, you cannot come here to be training here. And finally, we have the cost reduction for travel and accommodation. When we speak about training, there are two solutions for basically we have to bring the people that be training for one place, or bring the trainer where the trained people it is. With the virtual reality, we can avoid that path and just training wherever is the trainer and wherever is the people, without regardless the space, the physical space, because it's training in a virtual world, not in the real world. And that will save time and money for the projects. And then we have, again, maybe the most important for this project, the safety, the elimination of physical danger during trainings. Using VR training, we can avoid or eliminate all the physical dangers during that training, and reduce the physical danger during the real world training, because they know what they have to do. So it's expected that they will reduce the accident. Practicing the correct use of specialized equipment instead of spend millions of pounds buying expensive equipment, we can simulate that equipment in a virtual reality and training the people to use that equipment in the virtual reality for uh, a fraction of the cost that the real equipment could cost, especially in the construction sector. And finally, we have the simulation of rare or extreme situations, for example, hurricane or earthquake. We don't have to wait until we have a hurricane or earthquake. We can simulate it in a virtual environment to training people there. There are some spaces where the people can be training in the real world as there is an earthquake where the space is prepared to move the air and to have raining, but that is very very expensive because they have to move and make the real world be as that extreme situation, so that the spaces are very few in the world and are very expensive to build. With a virtual reality, that not will be an issue. And finally, we have the safe spot to high risk scenarios. Maybe the people is scared because before be training in the real world because they never face that dangerous situation. They never face that problem in the virtual reality. That can be avoided because they know will be really facing that problem, so they can be focused and relaxing during the training. And next time when they will be in the real world, they can remember that the last time they were focusing and relaxing, so they can still be focused and relaxing. After challenge, I would like to mention the movement sickness. There are documentation about the movement sickness. Many people express that they don't feel they feel sick when they are using VR. In concrete, we can speak about some research that say that 22.6% of women experience VR sicknesses frequently, compared to 7.2%. Additionally, 22% of women report symptoms sometimes versus 13% of men. So it's a percentage of people cannot be or can feel bad when they are using VRs. There are researchers on that. I don't want to bore you with this one, but they find that was because the distance with the pupil in women are different for men's. So for that reason, the women feel worse when they are using VRs. That research is for 2021. So after that, they try to improve that in future iteration of VR headsets. I try to say that yes, some people get feel bad with or feel sick with this virtual reality headset, but in the future, researchers are doing to improve and reduce that sicknesses. And then we have maybe the most important challenge for many people, but I will prove that it's not like that, is the cost consideration. Here you can see the 5 more buyed equipment for VR in the UK last year. And we can see prices for 399, 379, 1,299. So it's not really expensive use or buy that equipment. The prices are comparable with some phones, and if we compare that for a personal use, if we compare that with industrial use, with in the case of construction sector, um, that is insignificant in comparison with the cost that will be acquisition equipment for training in the construction sector. And that will be all. Thank you very much for your time. Thank you very much for being here. If you have any question, or if you drop any question in the QA, please let me know.
Excellent. Thank you very much, Edgar. That was really interesting to listen to. So thank you for that. Right, let's see. Let's have a couple of questions. First question we have is, Can you share examples of specific safety scenarios where VR has proven particularly effective?
Yes, we're working now in one training that basically is safety in fire scenarios where the people will face fire in the virtual world and they have to extinguish that fire. Again, they are not facing real fire, so they are safe in that moment. And next time where they will face fire in the real world, they will know what they have to do and they will remember that the last time they were okay with that, so they will be fine next time.
Excellent. Thank you very much. And then slightly maybe following on from this, our next question is, would this be suitable for someone who works in a factory?
Sorry?
Would the setup be suitable for someone who works in a factory?
Yes, it's totally suitable for something that work in a factory, because in the factories, obviously depends of the work that you are doing in the factories, but the normal in the factory there is a high voltage electricity. There are pipes that contain flammables equipment, so it's good to know which pipe. With the virtual reality training you can see which pipe have which pipe have air, water, steam, flammables. So you, when you face it in the real world, also if you don't know, if don't have the name, you can know because the order, and you can see, well, I remember that in the virtual reality that in which that was created for this factory, that was the order, so I know which one is this one. And obviously for high electricity, you can be prepared to walk in the area where it's safe or where it's more safe to walk, and also can be trained to use the PPE in the correct way. So when they are in the real world, they know which area of the factory are more safety for it in terms of electricity, and they know in which area of the factory they cannot walk in without PPE, for example.
Yeah, that's really interesting. Thank you. And yeah, definitely when you say, all PPE in the factory, finding your way around, yeah, it's a really great idea to have it in there. Thank you. And we'll just take one more before we move on to the next presentation, please. So we have the challenges of training that you've mentioned. What have you put in place to overcome it, either plans or processes?
I'm sorry, can you repeat the question?
Yeah, sure. So the challenges of the training that you've mentioned, what has been put in place to overcome these challenges, either ideas, plans, processes?
Yes, I am again about the big virtual sicknesses. There are many research on the moment. As I mentioned, that research that cut the gap between males and females. Uh, they try to make it more easy for people be adapted to the virtual reality. Still, the numbers are quite lower for males. Is 13% mentioned that sometimes feel sick, so it's not a high number. But it's expected that in the future that number will reduce because that's researchers. Also because younger people now exposed to this virtual reality. So in the future, no will be first time that they're exposed to this virtual reality. So it's expected that in the future, maybe 10 years, 20 years, that number will reduce significantly. And about the cost, all the time the cost of virtual reality equipment are going down. As you saw well, I show you in the pictures. I will share with you the presentation at the end. I put all the reference where you can see the prices of the object, and also reference for the papers that speak about this research. And you can see the comparison between prices is cheaper than many phones. It's comparable with buy phones. That maybe for one person that no will use too much in personal at home is okay, not very interesting, but for as for training purposes from the industry, um, will be more cheaper buy one of that equipment for training people that buy specialized equipment to be training every year with every new equipment, with every new version of the equipment that they have to be training.
Excellent. Thank you very much, Edgar. That was a really helpful answer. Thank you so much. Excellent. We'll leave the questions there for now. If anyone does have any additional questions for Edgar, please do send them and we'll do them at the end of the session. Cool. I think that might be
Thank you very much.
Lovely. Thank you, Edgar. We will now hear from Paul, founder of Tricor Technical Services. Over to you, Paul.
Thank you. Right, let me just share my screen. Okay, are we up and running?
Not quite yet.
Sound share.
Yeah, that's it. Thank you.
Okay, thanks for that, Edgar. Great introduction to VR. So my contribution this morning is more so about I suppose the reality, the uses, and it'll probably answer some of the questions which have been raised earlier. So we're looking at how we can use VR to boost efficiency as well as safety, and the sort of real world application of VR and the benefits that can bring. So the logic of the ordering of the webinar is, obviously we've heard about the introduction and the theory. This section will cover the use cases, the benefits, and the added value that can bring. And then following me, Abby will touch on some quite exciting AI elements that we are looking to integrate into the VR builds and the data optimization. So I will go. I am full of cold this morning, by the way, so if there's a few coughs and sneezes through, I'll apologise in advance. Right. So, yeah, myself, Paul Bass, work with Tricor Technical Services. Our contribution to the Extend project has predominantly been LiDAR scanning. We do a lot of that, point cloud cleansing, and then actually looking at the build of the VR and the interaction of you know, the processes, the actual triggers that we go through within the VR environment. Our background's basically looking at pain points with organisations, trying to focus on driving using technology. There's an artery of innovation running through the company, but we're about innovation, efficiency, and as I say, trying to utilise technology, which is rapidly advancing, as I assume everyone's aware, and using that to, as I say, certainly on this project, looking at the health and safety and the efficiency, and if we can keep people safer. Edgar mentioned it earlier, if we can put people in really, really hazardous situations, but be completely hazard-free, I can't see a better way of training people as to how they would respond to that. You are always going to have you know, my view is that you're never going to replace real training, but a bit of a topical thing at the moment, but you know, a blended learning solution where you have a mixture of theory, practical, and VR. I feel that's and we're certainly seeing a lot more companies being a lot more receptive to it. As the technology improves and gets quicker, but faster and cheaper, I can see that only growing. So whilst on that subject, again, a couple of examples of stuff that has been done in the past and where it's been used. I talk about the benefits after, but practical applications where you can pick up tools, project management where you can actually go into a site and access it remotely. The health and safety element of it, yeah, there's so many benefits. And as I say, I think the resistance to adopt and utilize VR now is reducing. Companies seem much more open to it, and yeah, it's it's very scalable. Edgar mentioned about the geographic restriction, but there's so many more benefits which I do cover shortly. So what I wanted to do is share some of the outputs. The project runs till March, but I thought it'd be a good opportunity to show what's been going on in the project, what we've been doing, and share some videos. So it's hot off the press, this. We released the first proof of concept video Monday, I think it was. So it's a pleasure to have the opportunity to share this on this webinar. But just to explain what the inputs and of how we've approached this project. So as Edgar mentioned, it's about looking at health and safety and hazards. So there was a feasibility and site selection. So we had to look at appropriate sites and actually identify something that we could capture, recreate, that would be a useful site to actually then generate the virtual reality and the training within that. So we went through that process and scanned a lot of numerous sites, and the capture method of getting that data and the technology. We selected a variety of methods and processes. So there was LiDAR cameras, there's a couple on there. There was drones with LiDAR. There was handheld stuff. So, and also we actually looked at the process of capturing the LiDAR as well in terms of how close together, the density, the tolerances. And the outputs that we achieved from this was a combination of photogrammetry, point cloud, and high quality imaging. Now, once we've been out there and we've captured, you can see here, I know sometimes when people look at it, they think that looks horrendous, but this is point cloud data, this isn't imaging. So, and that's the exciting part of this project, and certainly with the object recognition that Abby will cover shortly. So once this data has been captured and brought back to the office, the point cloud data will go through a cleansing and an optimizing process. And what we're trying to do there is actually take that site, highly accurate as well. The model that I'll show, we believe, is within 20 millimeters of reality. The data comes back, it's cleansed. We've overlaid the various technologies that we've used in the outputs to create a sort of shadow, if you like, of the site, and then that will go through a mesh conversion process to create the actual site. And the key thing here to mention is this isn't, a design. This isn't something that an architect's drawing or a CGI. This is actual measurements and actual point cloud data from the actual site, which I feel is something that's quite exciting about this project. So I'll very quickly just give you, we've used a house building site as an example, which between the consortium, we identified that this has numerous hazards. So this is like the effectively the photogrammetry output, but this here site with lots of hazards. There's excavators, there is tripping hazards, there is working at heights, falling objects. So what we did is we went around and, as I say, a variety of methods and captured that. And the plan was to take that information, take that, model that into, as I say, a shadow of that, and then start introducing the live training element. And I'll show that shortly. Let me just, I'm conscious of time here and I've got quite a bit to get through. So you get the idea, as I say, as well as the photogrammetry, there was a lot of LiDAR data that was picked up. So next step. What we then did, as I say, hot off the press, we've shared the first version of it, which is I wouldn't say basic, but it can certainly be improved upon, but it's visual and it gives everyone on the call something to look at. So we took the data. We've then generated a twin of the site. As I say, we believe that that's within 20 millimeters of reality, and we're still going through and checking various bits and pieces. But as I say, the exciting thing here is this isn't off a design. This is the actual site as it was when, obviously, another exciting thing for me is that if we went back and did it again, you can overlay and actually check the progress. Anyway, I'll continue. I could talk about this for forever, but the process we went through is the scan, cleanse, the conversion, and put that into mesh, and then generate and process the VR build. And we focused on accuracy, realism that will improve, but also the site, the one that we're focusing on today, had a fair amount of hazards. So that's what we're trying to focus on. Lots of different hazards and how you can immerse and engage people in there. And strictly speaking, anyone can walk around that site. You can see what the hazards are before you get anywhere near, before you have to put your boots on. There's other models being progressed at the moment, which again I think I touched on. And then the next step after this is the integration of the AI. So traditionally, how we do it is we would capture the point cloud data, and then it goes through various processes, but ultimately you end up with a mesh, and that's in effect one object. Abby will go through the steps, which is very exciting, associated with object recognition and perhaps split them into lots of smaller objects, which would make the process more efficient, quicker, faster, and cheaper. I will share the video. This should have some sound. I haven't practiced this, so hopefully it works. But this gives you a very high-level proof of concept view of what's being created. So yeah, as I say, this is within 20 millimeters of reality. of the actual site. If you look at the ground, undulations, hazards, ladders, etc. Now this isn't, just to explain, this isn't CGI. This is a VR. So you can navigate. If you had an area the size of the site, you could literally physically walk. And we'll show you shortly some of the stuff, very basic at the moment, but some of the stuff that we've put into it to do with hazards, and also the view that you get from within the headset. Should be coming up shortly. I hope this is streaming okay. It's again, we've got the option with environments, rain, wind, night, day, fairly easy to change those environments, which again isn't exciting. It's not fixed and rigid. There you go. This is the view that you will see, and the quality is much better within the headset.
Warning, elevated walkways and platforms require fall arrest systems and proper lighting. Ensure walkways are well lit to reduce visibility issues, and always report missing guardrails or unstable structures immediately.
Well, these are just examples that we've put in. We have got the text now, which needs to be compliant with standards.
Elevated walkways and platforms require fall arrest systems and proper lighting.
The porting that you can see there, if you do have a restricted place.
Reminder, open edges, such as balconies and large window frames, should be protected with temporary barriers or guardrails. Ensure tools and materials are kept away from the edges to prevent both falls and falling objects.
Where we're trying to get to is the interactivity, where traditionally VR can be very rigid, step 1, step 2, step 3. What you can see there, as I say, we are waiting for falling objects.
Equipped with tool belts or catch platforms to prevent falling materials.
And a lot of this there, for example, where you just saw something fall off some scaffolding, it's like that emotive response. If you are within an environment and you have an emotional response to something, you think, oh, that could have happened. You know, I think you're much more likely to take it on board when you are actually on the site. You know, even navigating where you're heading to, how do you get around the site, inductions. It's a lot of stuff that we've done before where, you know, people might want to have an induction on the site virtually, perhaps even before it's built. So there's a lot of, you know, now the base model's there, there's a lot of exciting opportunities to integrate additional functionality within there. And as I say, Abby will touch on that shortly when he covers the AI integration. Okay, so conscious of time, but I'll fly through here. So in terms of value, you know, my experience, what I've seen, I've already mentioned all about the blended learning solutions. You're never going to replace it. You know, for example, we've spoke already about fire extinguishers, the feeling of pulling a pin out, the pressure that you have to apply to it. You're probably never going to replace that. However, you can certainly put someone in an enclosed environment with the fire, get the feeling of what it's going to do. And I think a combination between all of that is the way forward. The benefits are significant. And outputs, so health and safety, I've mentioned inductions, I've mentioned immersive training, scenario, hazardous evacuation plans, etc. It's a lot of stuff that we've, you know, that we spoke with various organisations about. Training, even down to very technical, where some stuff we've done where you can actually strip cables, you can really intricate, and the technology is getting better and better. Tender and estimating, and my background as a quantity surveyor. I was a quantity surveyor for 20 years. There's so much potential associated with that. Stakeholder experience, you know, clients, engaging people. I think the opportunity for multi-user in the same environment is massive. Very exciting options with digital twinning, perhaps not in the house building, but, you know, someone mentioned about manufacturing or factories, integrating live sensoring and monitoring information within models. I can see huge potential for that. PM support, its most basic level, you have an accurate, you know, model of the site, you can immerse yourself and navigate through, and even something down to as simple as marketing and promotion. Right, hopefully I've done okay for time there. Chloe, any questions?
You have done excellently with time. Thank you, Paul. It was a really good presentation. Thank you. And thanks for including the video as well. I'm sure all of the audience will agree that that was a really great and helpful inclusion to have. So thank you very much.
Thank you.
We shall take a few questions as we have a few minutes. So the first question, Actually, it's probably quite a basic one for yourself. Could you give a definition of what point cloud is, or kind of explain it a little bit more in detail for those who aren't aware?
Yeah, so the point cloud data. So what we'll do is, and we do a lot of this, is we'll take LiDAR cameras out that will spin around, and it generates lots and lots of points which create a basically create the environment. So what we do is earlier on one of the slides you saw, there was lots of like speckly pictures that didn't look high quality images, and sometimes it puts people off. But what that is that is a digital replica of that environment. So we lift that up and take that back out, and depending on the kit, some of the equipment we have can be the tolerances as good as, I think it's 2 millimeters. It's 20 meters scans. So the actual measurement, and that's only getting better and better. It's the same with the drones. You know, the LiDAR can go down and it can generate these shadows and point cloud data of all the sites. What that enables you to then do is lift that out, bring it back, and then what we've done in this project is actually effectively draw around and create the environment. So it is, and that's one of the really exciting things about this. We're not doing VR from a design or a make-believe site or whatever. It is the site. So I think, you know, and as I say, some of the other tolerances is plus or minus 20 millimeters, but and with that data you can do a lot.
Cool. Thank you very much, Paul. Yeah, it was really good description of point cloud. So thank you. The next question is, where do you see VR progressing over the next couple of years?
So I think it's probably going to be the same as all technology. So it's going to get faster, it's going to get quicker, and hopefully I think it'll get cheaper. You know, the more it gets adopted. But I mean, if you take, I think Edgar spoke about the VR headsets earlier. The Meta Quest 2 was mentioned on there. That piece of kit, I think we had that 2 years ago. The latest model, or sorry, not even the latest model, actually, the more recent model was the Meta Quest 3. I think that's obviously much more powerful, but much smaller. I think very recently, in the last couple of months, the Meta Quest 3S has been brought out. So I think the response to that is, I think the technology is going to be rapidly improving, so smaller, faster. I also think there'll be more general adoption. At the moment, VR is very probably gaming and entertainment driven. But I think I can see that already with, you know, stuff that we're doing. I can see that getting rolled out across construction, healthcare, manufacturing. Yeah, and also in terms of you know, algorithms, and at the moment you can't process any of that within the headset. Long term, you know, there's going to be probably the ability to do that within the actual kit, but much more realistic, becoming much more mainstream. And yeah, probably more, you know, probably see a lot more headsets. Well, hopefully we see a lot more headsets over the next couple of years.
Excellent. Thank you very much, Paul. And yeah, very true. I mean, yeah, it is predominantly the entertainment industry so far. And it's going to be really interesting to see, you know, how much further this is going to progress into other industries. So thank you. I will take one more very quick question for you, please, before we move on. How is this different to other VR packages that already exist?
So I would say predominantly, which is good actually. So Abby will cover this, but it's the AI integration. I think once we get to the point where we're say taking that point cloud data, and when that goes through the conversion process into mesh, at the moment that appears as one object, and it's a very fairly manual and time consuming process to go through and create the digital shadow or digital twin, which depends on your definition. But what is exciting, and as I say, Abby will cover that, is it's about the object recognition of that data, and that will make it quicker. It will make it more efficient. You know, the speed of turnaround. Imagine we're scanning a site, and then you know, within a couple of weeks we can have that model there straight away. It's condensing everything, and yeah, the 3D, the point cloud to 3D is an exciting part of the project. I think the fact that we're using actual sites as opposed to made up sites, or sites that are based off a design, which are, you know, architects' drawings are all very well and good, but sometimes they perhaps don't reflect the true live site as it's been built. You know, there is a lot more hazards. So I think that's that makes us stand out. And I think the fact that you've got a multidisciplinary team across the consortium, you've got lots of input. It's not a VR company doing something. We're actively engrossed in a lot of industries, delivering work as well. So if you know what the pain points are, you can probably you're probably a better place to address them. That sort of practical industry focused approach. So yeah,
definitely. Thank you very much, Phil. That was a really great answer. And thank you for your presentation. That was really great to watch and to listen to. So thank you.
Thank you. I'm going to go blow my nose.
Yeah, you can have a break now.
Yeah.
And following on from Paul, we'll have Abby Oden, who is a research fellow at the Brunel Innovation Centre, which is a partnership between TWI and Brunel University of London. So over to you.
Thanks, Chloe. Good morning, everyone. And thanks, Paul, for that very interesting presentation. Let me share my screen quickly. Okay. Can you see my screen, please?
Yes, just need to pop it in the presentation mode. Yeah, that's the one. Excellent.
Okay,
Thank
fantastic.
you.
Thank you. Let me start with this by introducing myself. My name is Abby Oden Adeji. You can call me Abby. I'm the data analysis team leader at the Brunel Innovation Center. So at Brunel Innovation Center, what we do, also one of what the things we do is to apply innovative and technical solution to industrial problem. And how we do that is by coming together with industrial partners, either big businesses or SMEs, identifying the bottleneck in their process, putting that problem in a proposal, and then we send that proposal to either Innovate UK or Horizon EU. And if the proposal gets funded, we come together again to solve the problem, reducing bottleneck, and that is what we do at the center. And so if you have small businesses or you have large businesses and you're open to R&D collaborative project, please get in touch. That said, so the title of my presentation today is developing safer construction sites through artificial intelligence and VR innovation. I'm going to build on what Paul has already presented, so you may see some kind of similarities in what we are trying to achieve in this project. So someone asked a very interesting question: what is point cloud? I think it's very important to start from there, because that's exactly the question the AI integration is trying to solve. How do you define a point cloud, and what makes an object in a 3D environment? So if I can answer that quickly, point cloud is just a point in a cloud, right? And the point has coordinates, XYZ coordinates, and sometimes it starts color information, RGB information. So the combination of a lot of points is what is referred to as a point cloud. And I will show you a representation shortly. So building on what Paul has already presented, you have seen the virtual reality environment, you have seen how it is, and then ideas may be popping up in your head on what you can do in such environment. Because like you said, it's not just CGI, it's a real environment that you can interact with, you can do stuff inside that environment, you can lift stuff, you can break stuff without any consequences. So it's a very, very realistic environment that we think is very good for training, right? And other purposes. But you can always also see, like, it's very impressive the way Paul presented it. But what is much more impressive is the amount of work that went into that. You see, the scan, the clean, the convert, the mesh before it now goes into virtual reality environment. And some of that process is highly manual, you see, because what you see is not what the computer sees. So I will illustrate that shortly. So for instance, this is an example, an animation of point cloud, right? And if you look at this, you will see that is an example of a building, right, under construction. You can see the windows, you can see the door, you can see the roof, you can see the floor. You see, it makes sense to you, right? Because but it's point cloud. It's just an animation. This is 3D environment, right? 3D point cloud, I mean. But for the computer, this is not what the computer is seeing. This is what the computer is seeing. The computer is seeing a whole lot of points in the cloud. And sometimes that can be millions and billions of points just floating around. And the computer is trying to make sense of where is the window here, where is the door, where is the garage, right? Where is the floor, where are the pipes, you see? So to help the computers see the way humans see is the point of the AI integration we are trying to work on now. Because if the computer is not seeing the way humans see, then there is a lot of work for you to move from scanning to virtual reality environment. There's a lot of manual work. So what we want to do is to reduce the time that you need to spend processing your point cloud and making it useful in the virtual reality environment. And that is exactly what I'm going to be discussing shortly. So how can AI help in shortening this highly manual and highly labor-intensive and time-consuming process? So we do what Brunette does, right? We went online, we look at the literature, because again, there's no point in reinventing the wheel, yeah? So we look at the literature, we see what is available out there, and we came across SAM, right? SAM is an acronym for segmented anything model. It's from Meta, right? It is a very popular model in computer vision industry. So what SAM does is to take 2D images, right? Flat images, right? And you feed SAM that flat image, and it looks at the image and it recognizes objects in that image. For example, you can see what we fed into SAM just through the image of the scan I've already showed. And you can see what SAM does with that. It just recognizes the object. You can see that it has different color for the wall, different color for the windows, the door, and the floor, you see. So that's what SAM. So SAM is actually clustering those points that is everywhere. No, not points now, pixel that is everywhere, and making it make sense for the computer. So that is exactly what SAM does. But SAM takes 2D images, it's flat images, it does pixel to pixel conversion, right, or segmentation. It doesn't deal with 3D data, right? So the question is, how do we make SAM deal with 3D point cloud so that the computer can see 3D data the way humans see the 3D data? That is exactly the problem we solved using AI in this project. So what we did was look at, the question is not new, yeah? A lot of people have been asking this question before, and there are a number of trials that have been done. If you look out there, you see SAM 3D as an example of people trying to make SAM work for 3D environment, to process point cloud, yeah? You will see point SAM, you will see SAM Pro 3D, etc., right? This question, has been out there for a while, and they have been trying to, solve the challenge. But the issue with this approach is that most of them are very complex, right? And they don't scale well. The meaning of that is that sometimes you need to feed in point cloud and 2D images, right? Because SAM does image to image segmentation, not point cloud to point cloud, right? So you need a lot of point cloud sometimes. You need images, you need camera position, you have a lot of information that you need to feed in, for example, SAM 3D to work. And again, for our use case, virtual reality environment of a construction site, SAM 3D did not scale well for our use case. So we tried other methods. They didn't give us what we wanted. So what we did was to go back and look at what we can do to make SAM effective, work with point cloud. So we built different modules before SAM and after SAM, and we integrate those modules to make it work for point. That's exactly how we solve the problem. So the solution we came up with is called Smart SAM, right? And SMART is an acronym against 3D segmentation, meshing, and region treatment using segmented anything model. It's an acronym. And what makes SMART is that it has different modules. As you can see here, there's There's, of course, project setup. You have to set up the environment for the model to work, and then there's data processing. For instance, you see what pods shared. You have to do a lot of cleansing before you use the point cloud. So we want to automate that process. So we convert the data into useful format. Then we remove noise and outlier, because some points are just floating in space. They don't really have the information to the whole process. So you have to remove those points. Then we separate the grant from the non-grant object, just to make it much more realistic for SAM. Then, because sometimes points can be millions and billions of points in the scan, you can downsample. We have modules that make that enables you downsample if you need to do that. Then we set virtual camera, right? Because you recall that SAM works with 2D, right? It doesn't work with 3D. So we have to capture the frames, right, that represent the scan point cloud from different angles. So that's exactly what we did. We set up a virtual camera, and then we rotate. This is done automatically, by the way. We rotate the scan, and we take images from different angles, and then we feed these images into SAM, right? And SAM does what it does: digest the image and produce segmented 2D and flat image. But now we have to reproject from 2D to 3D, because we want point cloud, not 2D images. So that's where the edit came from. We have to do a lot of work in projecting from 2D to 3D, and then we convert to mesh. So these are modules that we added. This is some normal workflow that we see out there, right there in the middle. So this other modules are what we added as plugins for SAM to work with point cloud, right? And so it's interesting for you to note that other innovation we brought in here is that we take images from multiple angles, images of the point cloud from multiple angles, right? What you will see out there is people taking one image, but it doesn't actually scale well because it's 3-dimensional data, right? So we take from multiple angles. And then another challenge that we face while doing this is reprojecting from 2D into 3D environment, because for each pixel in 2D, you have to reproject the color, right, into 3D environment, and also other information, the texture information, the vertices, you have to reproject to 3D environment. And taking images from different angles and reprojecting is a lot of work, really. So after that, combining those is also a challenge that we needed to solve. So these are just things, the innovation that Smart SAM brings to the work. So you may be wondering what makes SAM really smart. What makes it SAM smart are the modules, the extra modules that we integrated into the workflow. For instance, you have to load point cloud first naturally. Now you don't have to do the cleansing yourself again, right? You do not have to do conversion yourself again. AI can take care of that. And you do not have to do the meshing again, right? AI can take care of that. So those processes are what we removed from the normal workflow of Tricor, and hopefully we integrate the two Smart SAM, and it does those processes automatically. So that's what we did. So this filter, like I mentioned, separate the ground from non-ground, and the virtual camera takes photos sent to SAM. SAM process the photo, segment the image, then we have to reproject. Again, that's where the real work is. Reprojecting from different images into the 3D environment is a lot of headache. So after reprojecting, by the way, we have point cloud output now segmented. You can see that SAM has already, you can see the wall, and you can see the windows. You can see those colors are just saying that these are different objects in this point cloud. So Smart SAM is able to recognize different objects. Even the floor, you can see it's different color. That's 3D point cloud, by the way. Then we convert it to mesh, and that is the output that we got from Smart SAM. So this is like a GIF output that shows what it is from 3D to 2D and from 2D to 3D reprojection. These are some images we took for using a virtual camera. This is automated pipeline, by the way. You don't see the camera, it's virtual, of course. So it's automated, it's part of the tool that we developed. So You take the camera, then we project. You can see that the wall is whitish now, meaning that those points that Smart SAM recognizes as the wall, it takes this patch of white color to it, so that if you want to reprocess this or you want to add the texture to this, it's easier. You do not need to manually do the segmentation again. It has already been done, right? You can see the color for the door, the garage is different, the floor is different, and all that. So that's what SAM does. Be conscious of time now. So Smart SAM is smart, right? But it's not perfect. Yeah. So this is what this is showing now. You can see for the GIF, for the animation on the left, Smart SAM did not perform well. Why? Because there are a lot of holes in the point cloud. So Smart SAM couldn't make out what the object is, right? And you can also see from the animation on the right, is a lot of complex building, right? Made together. So Smart SAM couldn't actually make up where the point should fit in, right? So these are edge cases because the point cloud, they have a lot of holes. If you want to see more of this and what it was before and what it is after, we can schedule another call to show you how the two works, right? So this just shows that we still have to improve Smart SAM on other edge cases, just like what we are showing right now. And you must also understand that this tool is zero shot and segmentation, right? Zero shot is that segmentation. That means that it did not take any training data because, of course, it's based on SAM, right? And then what we need to do to take care of these edge cases is to fine-tune Smart SAM so that you can see samples of our custom data, and then you can learn how to segment, even if it has a lot of holes. So that is the work that we are trying to improve upon now. So what are the benefits? Basically, what we are trying to do is to make Smart SAM see the way humans do. Like that is the end goal of all this. And because we have developed this end-to-end pipeline, you load in your point cloud, you get your mesh out. It's very cost effective because you don't have to move from one software to the other. Because normally you have to use Cloud Compare, Autodesk Recap, probably Blender to do this stuff. But if you can successfully do it using one tool, I think it's much more cost effective. And of course, it's flexible. The way we build this is like Lego blocks, right? You can remove one module and replace it with another, and the thing still functions. And of course, naturally, it now shortens your time to market for whatever product you are developing using VR, and it makes it much more realistic. So these are the benefits of Smart SAM. What is for is for everybody that is interested in point cloud processing. If your workflow revolves around processing point cloud, yeah, this tool is for you. Can get across, you can discuss how we can apply it in your own use case. If you are in VR, XR, content creation, yes, it's useful. BIM development, geomatics, these are areas that is easily you can easily use this tool. Of course, in robotics, because it's basically on computer vision, right? It's very useful in robotics as well. Be conscious of time now. So thank you very much for listening. I'll take questions now.
Excellent. Thank you very much. That was really good to listen to more about SAM and Smart SAM, and really helped to explain, it's a good follow on from Paul's presentation. So thank you very much. I will ask maybe just one quick question, and then maybe we can come back to some after Hazar's presentation. So the one I will take is, what are the computational requirements and how does it perform on lower end hardware?
Great question, Chloe. So for this tool, if you are using a mid-range GPU like NVIDIA RTX 4090, it takes 5 minutes to run. But the way we develop it, even if you have CPU, common laptops can run on your system. So it doesn't really actually consume a lot of computing resources in the development, yeah?
Cool, brilliant. Thank you very much. That's really good, for everyone on the call to know you haven't got to buy a really expensive supercomputer for it to work.
You don't need a big server for this to run. It's a tool you can run on your laptop, yeah.
Yeah, brilliant. Thank you very much. We do have a couple more, but I'll probably save them until the end if that's okay with you. Just so then we can make sure Azar can do his presentation on time, and then we'll do any additional ones later on.
No worries.
Lovely. Thank you very much, Abiodun. Great presentation. Thank you for your time.
Thank you.
We will now be hearing from Azar, who is a technology associate at VLab. So over to you, Azar.
Thank you, Chloe. I'll just share my screen.
Thank you.
So good morning and good afternoon, everyone. And once again, thank you for joining us today. I'm Azar Nalagat, Digitalization and Technology Associate at VLab. So I specialize in virtual reality, artificial intelligence, and 3D scanning for engineering application. My background is in civil and structural engineering, so I have contributed to large-scale projects that involving geometric road alignments and corridor designs. Currently, I'm focused on integrating advanced technologies into engineering workflows, like with the SafeXtend project. So in this session, I'll focus on the challenges that we face in the industry, the practical application of SafeXtend and the real impact it can deliver, not just for the workers, but for the employers and the entire construction sector. You have already seen the demo. So what I'm trying to talk about is how SafeXtend fits into your projects, how we can help you drive meaningful change. So, before I talk about how SafeXtend solves the training challenges, let's talk about what challenges are we addressing. First, we have the skill shortage issue. So the UK construction industry is facing a major skill shortage. Figure says that probably by 2030, the UK will need 300,000 more workers to meet demand. And at the same time, we are also dealing with an aging workforce. Like many experienced people are retiring, and the recruitment of the younger talent, the younger people, that is not keeping pace. So what that leaves us is a fewer skilled workers on site, and that's putting pressure on the projects. And that, with the inefficient training methods we have, like the traditional methods, like let's say classroom training, static presentations, which are costly and time consuming, and frankly, not very engaging. So in fact, attendance rates for these external training, they hover around just 25%. And even when these people attend, workers attend, the method is not always effective in preparing them for the real world tasks. And we have talked a lot about safety. The on-site training that we give people, the workers, that often exposes these workers into risky environments, especially where they are learning how to handle equipments or navigating hazardous areas. And unfortunately, the sad thing is that the UK construction sector has reported around more than 60,000 non-fatal injuries. That's a clear sign that we need better preparation and better training. And this is just not about the safety risks. We have another challenge there, retention capacity. Workers don't always remember what they have been told or what they have read during their theoretical training. And without the hands-on reinforcement, that's not always possible. Important details often get lost. This can lead to great mistakes when they are out on the site. Another thing is, if you take that retention challenge with the language barriers we have, so on many construction sites, especially in the UK, the teams are diverse. We have workers with different linguistic backgrounds. And yes, it's possible to translate the materials, but even when the materials are translated over to a different language, the concepts don't always resonate in the same way that's been intended to. And that will lead to confusion and inconsistency in like how the tasks are performed. So these barriers like safety risk, skill shortage, retention challenge. So all these highlight, all these are telling us why traditional training often falls short. But they are also showing us the possibility, the opportunity for the immersive, scenario-based virtual training like ours, the SafeXtend, can make a real difference. So my colleagues have already walked you through various aspects of virtual reality, artificial intelligence, and you have even seen the model in action. Now, let's take a step back and talk about why this approach works. So just to recap, what we have, SafeXtend. SafeXtend is an AI-powered VR platform, and the idea is to transform the construction workforce training, how it's being done. But what makes it particularly effective? So we already have a wide range of training methods available, right? We have the classroom training, we have the one-on-one session, safety briefings for the workers, we have videos, animations, and probably even other VR tools. But what SafeXtend offer is the ability for you to train your workers in the exact same site environment where they will be working virtually and safe. And when the workers train in a virtual environment, and that is an exact replica of their real environment, that will bring up a level of familiarity. And this level of familiarity can make a significant difference in how well workers retain and like apply what they have learned. So let's take a look at why this is important to retain this. So when we refer to concepts like what we see here, like the Edgar Dale score of experience, or let's say even from our own personal experience, it's clear that hands-on learning, when you experience that, it's far more effective than passive methods like reading or just watching some videos. And I believe that many of us must have gone through the experience of reading something, and 1 day, 2 days later, you might forget it. But if you have actually done something, actively gone through the motions, it stays with you. Let's apply that to construction. For example, let's say take fire safety training. So imagine an employer spends time and money on safety briefings and videos. So when they do that, the compliance boxes tick, that's fine. But when a fire drill happens, or worse, a fire happens, a real fire, what do most workers do? Some might panic. They might not know where to go or what to do. Many may end up looking for someone who seems to know what they're doing, so just so that they can follow them. But what if that person is wrong? And in emergencies like fire, split seconds can make all the difference. It might even be the case of life and death situation. Now imagine instead, these workers had already been trained in the same environment where they will be working with fire and everything simulated safely, of course. They have already experienced the scenario. They know where to go, what to do, how to stay calm. That's the value of immersive scenario-based training. It's just not about compliance. It's just not about ticking boxes. It's about the preparation. It's about instilling our workers with confidence and that instinctive response through the training. So this is just one example of how SafeXtend can contribute to like building a safer and more confident workforce. So just to recap things, I'd shown you how we discussed how SafeXtend is effective. So just to recap, let's see how it all comes together. So we start with your site. It's about you. It's customized. It's personalized for you. So SafeXtend starts with your site. We come with we have advanced 3D scanning technologies, as Paul mentioned earlier, to capture your every environment in every detail, every beam, every structure, every feature unique to your site. We capture that. From there, we create a virtual replica of your site. So and this is we are not talking about a generic training module. It's realistic and interactive environment that is tailored. That's your workplace. And workers can train in scenarios that can reflect the actual challenges that they will face on the job. And thanks to Abhi, here's even where it gets even better. As Abhi explained earlier, we are in the process of developing the AI tools that will help us automate the entire process, like converting the 3D scan into virtual and what it means for us. This will save significant amount of time and money. And that will help us a solution even more accessible and scalable for the employers. So once the virtual site is ready, we design persons VR training modules for you based on what you need. This can include safety drills, equipment handling, emergency response scenarios, anything. We can make the training match the needs of individual workers in your site and ensure that everyone gets the right level of guidance and complexity. So this is how we plan to, the entire process is prepared. And it will ensure that the workers are confident and safe even before they step foot on the site. Now, let's just go through some of the applications that I can talk about in this short time of SafeXtend, what we can offer. So these are some real-world applications, real-world challenges where the construction industry is facing. First one, refresher training. This is very crucial for the workers who have been away from the job for some time. So often when they come back to the site work, they might have forgotten small things, but really important details. And those things could affect their safety and productivity. So with SafeXtend, what we can do is these workers can step into the virtual environment, revisit their task, and quickly regain that confidence. And the way we do, give the hands-on way, we are improving the health and safety outcomes across the board. While coming to equipment-specific training, this is another challenge that we have. Workers often need to operate machinery or tools with different specifications from different manufacturers. That's not always possible, and it may be costly. And traditional training can't always cover every variation. But with SafeXtend, workers can practice using these machines virtually and reduce the risk of errors and help them quickly adapt to the new tools. So it's a flexible solution for every problem. Now, going back to the challenge that I mentioned in the first part, the language barrier, we have a diverse team here. And with SafeXtend, we are able to provide immersive, these virtual training that doesn't solely rely on like the written or spoken language. The idea is workers can engage directly with the environment, and it makes it easier to understand the task regardless of their language background. So this helps in reducing the errors and create a more inclusive training experience. And adapting to regulations. We have the regulatory compliance. As we all know, the construction safety regulations are like constantly evolving. And employers, they need to ensure that the workforce is up to date with the latest standards. So we have a modular approach. So we have the site in there. So we can quickly update the training modules to reflect any changes that you need and deliver those in a timely way. So these are some of the applications that I'd like to address in this part. And now, who is this for? What's the benefit that we are bringing to the table? I've already talked a lot about what the workers are getting out of this. We are offering them confidence and clarity. By training in the actual site environment, they're prepared for the tasks they will ever face. Any task, navigating sites, handling equipment, any emergencies, they are there fully equipped. They have the skills and knowledge that they need, and this will improve their safety and their productivity. Now, for the employers, the companies, we have a safe, cost-effective, and scalable training solution. This will reduce the time and money spent on traditional training methods and ensure that workers are properly trained and ready to comply with the standards. This is not just about saving costs, it's about like creating a much safer and more efficient workforce. And when we address the needs of our workers and employers, we address the need of industry. We address the challenges like skill shortage and need to improve safety culture on sites. So we have the solution that's designed for everyone. Whether you are managing, if you have a small team, you're overseeing a large scale operation, we have a solution for you. So mindful of the time, as we have explored today, SafeXtend is about more than just training. It's about preparing workers for the realities of the construction. It's about making safety instinctive, being there. It's about helping teams adapt quickly. It's about building confidence before they ever set foot on the site. We know the challenges of some of them I mentioned, like skill shortage and all these, and the need to keep workers safe in a complex environment. But with SafeXtend, we can turn those challenges to opportunities for growth and improvement. At the end of the day, it's not just about technology, it's about people. It's about giving every worker the tools that they need to feel prepared, be confident to perform better, and go home safe at the end of the day. So that's all from me today. If you have any questions, let's look into that. Thank you.
Brilliant. Thank you so much, Hazal. That was really interesting. It's really interesting to understand, it's not just one language that will be used for the system, it'll be multiple languages. So I think that's really helpful, especially I know we have people on the call today from countries all across the world. So that's really great to know. Thank you. Let's us take a couple of questions for yourself, and then maybe we'll go back to some of the other speakers and share some questions with them too. So the first question I have for you, please, is as someone who has never used VR before, how difficult is it for workers to get started with SafeXtend?
Oh yeah, that's good. So to be honest, getting started with SafeXtend, the way we have designed is it's simple and as intuitive as it can be. So you don't need to be a tech expert or have to have a prior experience with VR to use it effectively. So the idea, let me give you an example. Like we have had different kind of people. So some people are excited to try the VR headsets on, but some people are a bit reserved. Some people are like anxious. They say, "Oh no, I don't want to try it out at all." But we will give an orientation. But SafeXtend, the process straightforward. They put on the headset, and from the moment that they step into the virtual training environment, the system guides them what to do. Everything is interactive in there, and it's user friendly. So for example, if they are learning like to operate something, the system will show exactly where to position their hands, what to do, and all the steps. And the great part is with the VR, you can take your time. If something doesn't feel right, like they can pause, they can retry, ask questions. And the great thing about this, we have fun people actually enjoying the experience. So it's engaging, and I can say it's even a bit of fun. So even if someone has zero experience with VR, they can start using SafeXtend with confidently, like within minutes. And we also provide like onboarding and support to ensure that everyone feels comfortable. So it's all about making that everyone's included regardless of their, let's say, technical background.
Cool, great. Thank you so much. That's really, it's really amazing to hear. And again, I'm sure lots of people will be pleased to know that they don't have to be very experienced before trying it. Thank you. The next question I have for you, please, is how does SafeXtend customize training for different types of workers or roles on a site?
Okay. So if you got two workers, so let's assume that you have one worker who's new to the job and other who has years of experience but need to brush up on their, let's say, updated safety protocols. What we can do is the new worker, we have the site in the virtual world. So the new worker can get started with this basic site orientation, learn what the safety zones are, familiarizing themselves with the layout, understanding where the entry and exit is, things like that. Same time, the experienced worker can skip those, go straight into the advanced modules like handling new piece of machinery, practicing emergency drill. Also, with we can also account for like role-specific training. For instance, maybe a supervisor might focus on hazard identification or like project management things, while a technician can practice like handling equipments or operating tools and like that. So it's adaptable for everyone. Yeah.
Excellent. Brilliant. Thank you very much. I think we'll do one more question for yourself, and then maybe I'll go to Abiodun for another one for him. So the last question I have for you, please, Azar, is how does using VR in construction training help compared to just watching videos or attending a class?
Let's just take one example for this one. So maybe responding to a chemical spill. So that's a task where you need speed and being able to make being able to make decisions calmly. And these are absolutely critical. So in traditional training, we have videos, attending lectures or things like that, identifying the chemical, wearing the correct protective PPE, containing the spill, using the right material. So that's great for theory. But when they're like actually on the site and still happens and one worker has to do something, they might not really exactly remember it. So this is where like VR really stands out. So we like supplement the original training. So in the virtual environment, they are placed directly in the scenario. So when a spill happens, they have to identify the type of chemical using the labels, select the PPE, use the correct tools. And so they're just not learning the steps, they're actively like applying them. And it's a thing in the VR, if you make a mistake, let's say you choose the wrong gear or delay your response, you are slow, and you can immediately see the impact. So the simulation will show that you are slow, the spill is spreading further, PPE failing. They can redo it over and over. So that's the idea. So it allows the workers to practice and perfect their skills until they are completely prepared.
Excellent, great explanation. Thank you very much, Azar. I think I'll leave it there for questions for yourself. And thank you very much for your presentation. That was really, really interesting. Thank you. Abiodun, if you are still there and you haven't run away just yet, apologies, I only gave you one question earlier, so I thought I'll come back to you now to ask another one before we wrap up. So in your presentation, you went into a lot of detail on the Smart SAM. So this question is going to be in relation to that. So it's what are the future directions for Smart SAM? Are there any plans to expand its capabilities?
Interesting question. Thanks, Chloe. So yeah, there are a couple of plans to expand on this capability, because we are trying to make this tool very flexible, and we are trying to make it bespoke as possible. What that means is that, for instance, let me give you an example. If you want to, for instance, in a point cloud, you want to segment one object, not all, because Smart SAM currently segments everything in the point cloud. What if your interest is just one object? You just want the door alone, for instance, in the example I gave. So can you type, give me the door alone, and then Smart SAM does that segmentation for the door alone and give it to you? Yeah, that's one possibility that we're exploring. And to do that, we have to integrate another kind of tool. It's a natural language processing tool called Grounding Dino. So that's that's how we want to proceed with that. Another thing we want to do is to put a very intuitive user interface on the algorithm, so that all you see is a user interface that you can upload your point cloud, and then you get your mesh output. And then you can probably play with some kind of parameters depending on the output you have to make your mesh much more realistic. So those are some of the improvements that we are looking at currently.
Excellent. Thank you very much. Yeah, that was really useful to learn. And I guess, it's just helped people understand Smart SAM more, and there is more of a future coming forward as well. So thank you. I will look to wrap up the session now. We do have a few more questions, but we do also, everyone is probably eager to go get some lunch at this point. if anyone does have any further questions they would like to ask after today's webinar, please either email myself directly, which is chloe.sparks@twi.co.uk, and I can pass them on for you. Or alternatively, please do reach out to any of our speakers via the email address of info@safextend.co.uk, and they'll be happy to go through, in more detail with you on a more one-to-one level and explain things in further depth, and potentially arrange any future calls with yourselves. So thank you to all of our speakers for today. You all gave excellent presentations. They were really interesting to listen to, and I'm sure the audience really appreciated them too. Anyone who is interested in seeing the slides afterwards, please email us directly, and we can send a copy of those to you. And yes, we thank you for joining us. It's been really great to have you with us today, and hope to see you soon, and enjoy the rest of your week. Thank you, everyone.
Thanks, Chloe. Bye-bye.
Thank you.
Thank you, Chloe. Thanks for facilitating as well.
No problem at all. My pleasure.
Bye-bye.
Right. Thanks, everyone. Bye.